that class. We have to make up for that class somehow. And we also started late. I don't know if we started late by 2 weeks or 1 week. Can anyone tell me is there any impact on when your internal exam week is going to be now, or did they announce it? Is it next week? Is it week after? You can put it in the chat for me so that I would know, right? So I was going to cover the stack implementation using array. So I did post a slide deck, so we covered that in the class because we did not really have a class last week. Okay, just a quote. 16 this one, that's good. I'm glad it is 16, so we have at least one more week to work for. And then when we started it, we said that we will have some makeup class for last time. So I'm assuming that that is being scheduled also, like on a Saturday or Sunday, whatever works for you. And we're happy to do a couple of extra classes so that way all the students are ready for the internal exam. That's the quote of the day. We've given an education quote as just giving because you're all tomorrow's leaders. A good leader takes a share of the blame, a little less than a share of the credit. Remember that. When you are successful, give credit to the team. When something doesn't quite work out right, you take it on you. That is a sign of a good leader. That's what it is. Okay. I gave a quick fun exercise on pointers, but then since we missed the class, I'm going to leave it like that. I'm not going to do that exercise again. It's good since you're C programmers, it's good to review pointers. Pointers are everywhere, right? So you may want to review it on your own. If you have any questions on that, just email them to me. Okay. So what we will focus on is really stack implementation using array in this class. Earlier, we saw the stack implementation using pointers. So I gave the entire segments of code for that. I'm hoping that you would be implementing those pieces of code in C language, and then in the process of debugging code and all that, you would learn how to write a stack implementation using linked list. The second aspect of that, as we mentioned in the beginning of the chapter, is you can also implement stack using array. Okay? So we would be looking at code samples as to how we would do that. Okay? Then we get into some applications of stacks like reversing a list and so on. So that is the focus of today's class. Okay. Let me make sure my chat is open here in case somebody. Okay, great. And so if I go a little bit fast, you can slow me down. Put it in the chat. You can scream at me saying, "Sir, you're going too fast." On the other hand, if I'm going too slow, also you say, "Can you speed up?" Both are fair game today, because I want to make sure we finish this slide deck today, and then a couple of things in the next class, and then get into module 3. Okay. So let's look at this without any further ado. What happened? Okay. So include stdio.h. We all know why we do that, right? That's what provides your input-output functions. Okay. Found define. So that's what you use to define your constants. So you're defining a constant max size with the value 5. Okay. Since we are doing it as an array, how do we do that? If you look at the struct stack, we're calling it stack. Please mute yourself, whoever joined late. Otherwise, I have to again stop screen and then mute you. Let's see. Bodhisetti Santoshi. Okay, I muted. Pragati. Okay, I muted Pragati. Hopefully there is no static anywhere. struct is a record, right? So struct stack, and then you're declaring stack as an array. That's why you see int stack max size. So your stack is going to be stack 5. Okay. Now remember, one of the fundamental principles of stack, we said you need to know the top, because when you're topping, you're always topping either at top or top -1 +1, depending on how you define top. Okay, we'll see that. Okay. So this is only, you're declaring the data type, right? Struct stack is only declaring the data type. You have not declared the variable stack yet. Okay. Now, what does the type def do? Why do we do type def struct stack? By default, when you do the word type def struct, what you're doing is you're creating a synonym for that big struct stack. Okay. So when you say type def struct stack, what it means is later when you're declaring variables, you can simply use the word stack, the capital stack, as opposed to saying every single time struct stack f. You simply start saying stack f. So that is what you're seeing here. Sorry, stack f. That is this line. Okay. Now these are called the next. What do we do with respect to stack? We do push. You see void push. Okay, and pop. Okay, and then display. Display means contents of the stack. These are forward declarations that you have to do in C programming. If you know the from C programming, if you don't do that, since the compiler would give you error because it won't compile. By doing the forward declarations, you're telling the compiler, hey, the functions related to these things are coming forward. So the compiler knows that, these are not invalid, it is coming. Okay? Now let me go to the next slide. Okay. So what are we doing here? Main. Remember, every program, C programming has a main. Okay? Okay, so we have main. You declare a couple of variables called choice. We'll see how we are going to use it. Now, programming, in Programming 101, we are taught that whenever you declare a variable, put a comment around that, right? Here it's a little bit cryptic piece of code, but we'll see what is the semantics of choice. Okay? Same thing, what is the semantics of option. Okay? Now you can see initialize the variable s.top. S is your stack that has been declared, right? And then you say s.top, because that's how this dot notation is accessing the elements of the structure, right? So you're saying stack.top because that is what we declared on the previous slide, as you can see. Let me go back to the previous slide once. See, stack structure has two things. One is array and the other one is top. So you say, since stack has been declared f, you say s.top. So you go to s.top and you are initializing to -1. The reason why you're doing -1, you will know it quickly, because whenever you need to push an element into the array, you increment the top and then you push, and this s.top -1 comes in very handy in one particular function that we will see shortly. Okay. Printf, you know that it's the constant. You're printing this phrase stack operation. While option, so you see how the option is being used. Option is being used to go into this loop, and then you're printing the structure here, displaying the structure and saying, hey user, if you want to push an element, okay, enter 1. And if you want to exit the program, enter 4. Okay. And option is equal to 1, meaning while true. Correct? 1 is true. That is the default value. So now when you come to the down statement here, printf enter your choice. You are going to do an ampersand choice and then you do %d. So basically what you're doing is you're saving that into the variable called choice. So what was the user's choice? Okay. So far so good. Okay. And I'm assuming all of you are able to hear me well. If anyone has difficulty hearing me, put it in the chat and Jntuk will solve your problem. Okay. Now, so you have choice. So when you have choices, you learned in C programming, you use a switch statement, right? Could you have used an if-then-else statement here instead of a switch? Yes or no? Here we are using switch. Could I have used an if-then-else statement here? Or if-else, basically. In C we call it if-else, right? The answer is E. But why do I use switch? Your professor in C programming would have taught you that, right? Whenever you have more than 2 or 3 choices, you use a switch statement. Much more readable, right? If you write nested if else, the code gets pretty messy soon. So anything beyond if else or else if, the moment you go beyond 3, you use a switch. Okay. Now, how does the switch statement work? You say case 1, case 2, case 3, case 4, because we have four things the user can enter, right? What happens if the user enters 5? Think about it. Okay? You don't have an answer, but think about it. Somebody wants to answer after some time, you are welcome to do that. So if it is case 1, it is push. So, and then you have to use if you recall from your C programming, after each of the cases, you do a break. Meaning you come out of that particular switch statement. If you do not have the break, then the code will go to case 2, then case 3, case 4, and so on. So break means you're coming out of the loop. Okay, same thing for pop, display, and return. Okay. Now flush stdin is the one where it is flushing the buffer. As the user inputting these things, they are getting stored in a buffer internally, and then you want to flush out the buffer content. That's what flush is. Okay. Form something. Then you are asking the user, okay, let's say user entered 1 first time. You do push. So after you do the push, then you say printf, do you want to continue? Type 0 or 1. Okay. Then you read that value. If it is 0, that means you are basically saying, hey, I don't need to continue. Okay. Now let's see what this is. I think the code went beyond. Give me a second, I need to adjust my. Okay, so while option, we did case 1, case 2, sorry. Printf, okay. All right. Now, let's look at the pieces of code here for each of the things, right? How does push work? Okay. Conceptually, you have to, now you're pushing it into an array, right? Does array have a fixed size? We know that it is a fixed size. So what are we doing? First thing we check in push operation is, hey, if s.top equal to max size minus 1. Because max size has been declared as 5, right? Okay. Now 5 means our numbering in programming starts from, in computer science starts from 0 to 4, correct? So that is the reason why it does a max size minus 1. So max size 5 minus 1 is 4. So if s.top equal to 4, that means stack is full because the array is full. I'm assuming you're following that, right? A simple piece of code there, right? So you want to push, before you push, you want to make sure that the array is not already full. That's all you're checking there. Okay? Now, if that is not true, then you come to the else branch, right? Then you're asking the user, enter the element to be pushed. Okay? So whatever an element that the user is pushing, then you do s-stop equal to s-stop plus 1. Why do you do s equal to s-stop plus 1? Because s-stop initially is pointing to minus 1, if you recall. When we initialize s-stop, we initialize to s-stop equal to minus 1. But by incrementing that, you are basically making it the 0th element. Remember, the elements of the array start from 0. So if it is the very first element that's getting pushed, s-stop equal to s-stop plus 1 basically gives you 0. and then you then push the element, meaning assign the element. That is the push code. Let me pause here for a second if I'm going too fast. I'm looking at DMS VHC video. You can tell me, show of hands, do you understand the push code? I kind of see only the heads of it. If you can fine-tune the video to show them a little bit more, that would be great. DMS SVHC. Okay. That is the only video that I'm seeing, or am I seeing other people's video? Let me check. Yeah, that's the only video that I'm seeing. I'm seeing Jntuk Kakinada. Okay, show of hands if you understand the push code. You have to raise a little bit higher because my resolution is not that great. Yeah, you are raising your hand. That's good. Excellent. Very easy, right? So programming actually, that's why it's fun. It's very logical actually if you think about it, right? Doing modular programming like that makes our life much easier. But I'm not saying that you get it right the very first time you write the code, okay? I have not met a programmer who has written code correctly the first time. It's always debugging is what makes you, okay? Okay, so what did we learn here? Key concepts. When you're implementing stack as an array has a fixed size. So you have to define what the size of the array is. So whether it is 10, 20, whatever, okay? Now you need to initialize the variable there internally, like s.top equal to -1. Okay? And then of course, whenever you need to push, you have to increment the top and then push the element. Now before you push the element, you always want to make sure the array is not full. Okay, okay, so far so good. Now the fun begins. It's all hands-on, guys, today. Okay, in groups, faculty members, please facilitate that. Okay, here is an exercise. I showed you push. Okay, you can trace it. You have an empty stack, A0 to 4. You pushed one element. Okay, I want you to delete an element from a stack. Deleting meaning, in our stack language, it's called popping an element. Okay, just like how we wrote push, I want you to write the pop function. Okay, time given is 5 to 7 minutes. Okay, I will put the push code here for reference. Okay, next 5 to 7 minutes, I want Bridget to working on writing something called pop, just like that. See how it fit nicely in one piece of one slide there. Okay, write the pop. Ready, set, go. If any college is finishing it in 2 minutes, when you post the code in chat, put it in private mode. I want others to exercise their brains for until 5 minutes. I can see Jntuk Kakinada working. Let me see if Chaitanya, do you have video? You can turn it on. Same Usharama College in IIT. If you have video, you can turn it on. I can see your students. Jntuk Kakinada, you said the exam is on 16th, but I hope there is no vacation next week, right? We'll all be at the class, I'm sure. Even if they give holidays, one of the students comes down. JNTV, you follow the question, right? I'm hoping that you are writing the pop function based on how we wrote the push. I'm muting you. Good morning. morning, Jntuk. I know you joined a little bit late today. Jntuk class is always packed. Do they have more students in that college or what? I can turn on my video for a little bit. Okay, I see them working. Let me see. DMS SVXC, కొంచెం your camera you have to adjust so that way I can see the students. Right now I see barely the top of their heads. Pragati, I don't see any video. Aditya, Bolisetti, Santosh, I don't see any video for you. Chaitanya, I don't see any video. Looks like Chakravarti Garu joined. Good morning, Chakravarti Garu. If you are there. There you are. I like your baseball cap. Did anyone solve the problem yet? The exercise is to write pop function, just in case who joined late. I said delete means basically pop. How do you pop from a stack? I think a whole series of exercises, complete hands-on classes actually one. Okay, I see Jntuk students relaxing, that means they are done. If somebody is done, you can put it in the chat in private mode for me. Somebody is typing void pop. So faculty members, you can kind of give, you can put some your things in private to see how your students are doing, because I can't see them all. Not all of them have videos. Please feel free to put it. These are all fairly simple programs, so but interesting, good programs. So. Okay, I just saw void pop, open parenthesis. After that, I didn't see any other thing put there. One more minute and then we'll move on, okay? Time goes so fast. We should extend this 2-hour class to 3-hour class. That's very good. Jntuk is basically giving solution to everyone instead of putting it in private. You got it. That is exactly what I was looking for. It's s.top equal to -1. And why do we check that? Printf stack is empty. You got it. Perfect. Okay. Else? Else s dot top equal to, you mean s dot top? Do you type it correctly there? You first pop and then decrement the counter. So you say, you should have said s equal to, f gets s dot. There. Okay. S, yeah, there you go. Now I can, perfect. There you go. You got it. Excellent. I got answer and we put that there. Perfect. I'm super excited. Thank you. Now let's go to the next slide. That is the piece of code there. Okay, for the rest of the class, you can see the Ezra top. So I chose printing the element. Whatever is the popped element, you just have to do printf, right? And then you get that. Okay, very straightforward. Okay. What else we can do? Next 5 to 10 minutes. See, today there is no rest for you. I'm making you work very hard today because you missed one class. Okay, let's get going for the next 5 to 7 minutes. How do you display the contents of the stack? Now, JNQV, I know you will solve the problem in 1 minute. I don't want you to put any answer. And I do not want JNQ Kakinada also to put any answer yet. I want other colleges to put the answer first today. Okay, let's have a friendly competition here, okay? Chaitanya, Chaitanya, Aditya, DMS, Pragati, for displaying the contents of the stack. Now, JNTV, I asked you not to put anything there in the chat. Don't. I want one of the other colleges to put something there. Students under Venkal Justna, JNTV, to tell the instructor not to put anything there. But you can do it on your piece of paper. I didn't say you should not do it, you should do it. And I want others to put the answer in the chat. This way you're displaying the contents of the stack, right? So I'm assuming there's some kind of a if statement and there's some kind of a loop statement, some kind of a looping. So, just out of curiosity, why did all the students stand up in JNTUV? Was it just for stretching or did somebody come into the room? Colleges, please, other than JNTUV and JNTU Kakinada. You're all smart. Every college student is smart, okay? Okay. I'm just going to give this. I don't know if JNTU system has any hackathons. In US, hackathons, weekend hackathons are very popular. So maybe one of you professors can start doing some hackathons there to motivate students to do a lot of programming on the weekends. That might work for JNTU. Yeah, I'll select everyone. Any answer yet? It shouldn't take much time. For JNTU, we already showed you how to do POP. Okay, I'll open the chat to everyone. JNTV was eager to put something there. Go ahead, JNTV. You can put it now. All these colonies generally they are very fast. They do that. Unless they are shy today for some reason. Okay, no one put the answer. There it is. I am putting the answer for, oh, you are already putting it. Yeah, you got it. For I equal to 0, I less than top, you got it. Yeah. Of course, you want to first check the condition, right? That it's not an empty stack, like how JNTV put it. Okay. Yep, you got it. So you're basically checking if S top equal to -1, right? Remember, we initialize to -1 because Y is an empty stack, that denotes empty stack. So whenever you're popping out or displaying contents, you want to first make sure it's not an empty stack. If it's an empty stack, there's nothing to display. Stack is empty. Else, you do the for loop. Okay. Now, when you set the for loop, right, chances are, even I'll do the same mistake. Where would the I start from, right? I has to start from S dot top, and then you have to decrement it, right? Because you pop the element out, you have to keep decrementing it. In this case, there is no decrementing, there is no pop, because it's an array, you can keep decrementing the index. That is what you are doing there, okay? Believe me, once you get a hang of it, it's very easy, okay? Okay, that is done. You got it, JNTU, Kakinada and JNTV. Okay, last one, okay? I showed you the code, okay? What we'll do is we'll not do this exercise right now. I put it originally because I wanted to make you understand how we test, right? So if you have a piece of code already written, just trace it, okay? How do you trace it? You push an element, pop an element, display an element, and exit. These are the 4 paths, right? That's all we had there, remember? So when you are going to become a QA testing person, that's what we test. We test the functionality. That's one aspect of it. If you talk to me, I test not only functionality, I test security also, depending on what your objective is. But first thing that we have to test is functionality, that it is working, right? And these are the 4 things that can be done, and then you will test all of them on your piece of. That you catch errors in your code or design logic and then modify your code accordingly, okay? Where there is development, there is an immediate testing also that goes with that. Okay. Okay. So we basically saw 2 ways of implementing, right? One is linked list, where we have to get the memory allocated. Remember the malloc? We did a malloc, a new, and then we allocated that, and then there's a pointer assigned to that. Wherever there is dynamic memory allocation, you need to have a pointer pointing to that. And then we saw the second variation of a stack implementation using an array, where array size is fixed. Okay. Now in real life, we use stacks everywhere. I showed you a lot of examples, right? Pictorial examples. But here are some things which we typically use the stack application for. Okay. So I'm going to cover two of those things today, I think. Okay, and then you are going to take a couple of these things as a take home. We'll just simply discuss them in the class next week. Okay, so let's look at reversing a list. Okay, I think there's some more hands-on related to this. So what does reversing a list mean? You are given a pointer, okay, to the head node. Okay, the task is to reverse the linked list. Okay, simple explanation. And I am giving you an example there. It can't be much simpler than this, right? Input is head of the following linked list. The list is shown as 1, 2, 3, 4. Reversing a list means basically 4, 3, 2, 1. So go to 4, 3, 2, 1 now. Okay. Another example. 1, 2, 3, 4, 5. You get 5, 4, 3, 2, 1. Okay. What happens if the input is null to your function? There is nothing to reverse, so output would be null. Same thing when input is equal to 1 and the pointer is found null, the output is 1 and then null. The reason is the two conditions, input null and input 1, basically show it's either a zero element linked list or a one element linked list. Reverse of one element is the same as the one element. Okay, so in the process of showing you the examples, I am also showing you what you should be checking for in your code, right? You should always check for one element and empty element whenever you are talking about arrays, whenever you are talking about stacks. And of course, you have to also worry about the top element depending on how you implement it. Okay. So here is reversing a list. Okay. I'll be totally quiet for the next 3 minutes. Okay. I'll put myself on mute. I want each student to assimilate what the code says there. Okay. 3 minutes of silence from me. Not because somebody died, I'm just making it silent so that way I can look at my coffee. Okay. I want you to look at the code, understand what it is doing, and if you do not understand, draw it on a piece of paper. While I understand. Got it. Got it. You are unable to hear me because I was on mute. Thank you. Okay. So you can put that in chat too. How come I didn't see your chat? Let me see. Okay, I'm taking control back. Give me a second. Okay, there you go. You put it there. Okay, got it. Thank you. So what was I saying? So basically, what I was saying was, you can see how I traced the code, right? The question that I asked to Jntuk, Kakan and others was, how many of you, when I asked you to understand this code, started drawing some things like that on a piece of paper? That was the question. No wonder nobody raised the hand. Did anyone draw anything on a piece of paper to understand the code? Is what I asked you. Okay. I don't know about you folks, but I can tell you I can never understand the code without drawing some pictures like that. Okay. So, but you can see how in the process of building these nodes, I just went line by line and drew these things, and it was so crystal clear to me. Okay. Now, once I have some elements here, 4 was pointing to this one, right? It was not null. It was pointing to this one. And then you had 20 here. And this one was the last element of the list, so you had null there. So to do the reverse of this, basically you want this arrow now should be, this should be a first element, 20 should be a first element. This arrow, instead of being this side, it should be the other side. Okay? And then this will be your 4, this will be your null, and this head would move to here. This is your head basically. Okay, this is no longer null. I should put value here, like this, and this is the link to the next node, right? So you can see current dot next, and head, to be precise, is pointing to the node here, like that. Okay. So if you follow this piece of code with these 2 elements, convince yourself that is what is happening. You have a head, okay, and then you have a current. Current not equal to null, meaning you always want to make sure that you have not reached the end of the list. Okay. So you need current, you need previous, and you need head. So 3 main concepts are to traverse linked list. You need head, you need current, and you need previous. So reversing a list basically is about manipulating these 3 variables, head, current, and previous. Okay? And I've given you all the piece of code there, and you trace it. Okay? We'll trace it later on at the end of the class. Okay? Right now I'll move on, and then I'll give you enough time in the end to trace all this code. Okay? Okay. That's the driver program that we started with. Okay? I'll make you trace it towards the end of the class, as I mentioned. Oh, again, hold on to this exercise. We'll do it after I finish a couple of other slides, okay? So there's another part of reversing a list, right? I said what I showed you was kind of like one way of doing it. There's an iterative method also where you can go to the linked list, and in a loop you're changing next to previous, previous to current, and current to next. So if you know this order, right, next to previous, previous to current, and current to next. If you know that order, then you know how to do the reverse of the list. The concept is very, very simple once you know those three. Okay. Now, one more thing I will introduce you, then I will let you do some exercise, okay? So, the second example of using the stack application is factorial calculation. So I just copy-pasted the code from one of the code samples that I have access to. So let's understand what he's doing here, right? Again, programming is not really taught, it is learned by doing, right? I'm giving you all this piece of code so that way you can trace it on a piece of paper and then also rewrite this in your C compiler and execute and then tell me you understand, right? Okay. So, how do we calculate factorial? Everyone knows factorial. I'm not going to tell you what factorial is. We know that, right? 2 factorial, 2 times 1, 3 factorial, 3 times 2 times 1, and so on, okay? N factorial, n times n minus 1, n minus 2, to 1, okay? So, in the main, we have a number. We are saying that we are going to implement the factorial using stack, because since we are stack, and stack further is implemented in array, okay? So you are saying enter the number whose factorial is to be found. We are telling them enter any number from 1 to 9, okay? So I enter a number and then I print. Then you do the get char. You know what get char is, right? Again, it prompts the user. That's your main program, okay? Main should be very small. Remember, good programming principles, main should be very small, because everything else will go into the functions. Okay. Now, how do you display? So when you do the factorial, you say, okay, the stack is, now you are going to say for I equal to 1, I less than n, I plus plus. So you are printing all the elements of the stack. And of course is the size of the array. Okay? That is display. Remember, we had display. What do we do with stack? You display, you push, you pop. Okay? Now, so pop, if n equal to 0, in this case, remember in the earlier case when I showed you, he initialized the value with minus 1. Okay? Here in this case, they are starting with 0. Okay? Different algorithms, right? So if n equal to 0 in this case, stack is empty. Okay? Else, if the stack is not empty, then what do? You want to get the result of the factorial. That is, stack of n, whatever that n value is, then you're decrementing it and then displaying and then returning the result. Okay? Because the result is where you're getting the value of n there. Okay? Now let's see what happens there. Okay? Push. Similar concept. When you're pushing, if n equal to n, okay, because your stack has been implemented as an array of 10 integers, and then n equal to n means 0 to 9, stack is already full, you cannot push. Else, whatever n is pointing to, you increment the n, and stack of n gets the value of x. Okay. Next on the right, you see the factorial integer num. So if the number that is passed is 2, okay, then they push 2, push 1. Okay. Now, then you continue like that, right? If the number is not 2, somewhere here I think I missed one parenthesis. But if the number is greater than or equal to 1, then you continue to do results star equal to. What we are doing here, basically we are multiplying. Right? Star equal to basically is multiplying and assigning the result, right? Pop. So you push, let us say you pushed 3 elements, factorial 3, 3, 2, 1. So you are popping 3, you are popping 3, and then next you are getting popping 2, and then next you are popping 1. All of those things are getting multiplied, and then the result is being stored in RES. Okay? That is what you're doing here. Now again, when you write this code, it's easy to say, okay, here is a piece of code. Unless you write it, you would not appreciate it. But this pretty much gives you the driver program, right? If you can write this much, then you go back to your main, okay, and you give some number here, okay, and then you're calling, first calling function is this one, fact num. Let's say the number I pass is 3, okay, so I'm tracing it for you now. Let's say I pass number 3 here, okay, fact num. So I go to fact num. Where is fact num here? Fact num, push pop, fact num, okay? If number equal to 2, number is not equal to 2, so I would not execute any of this code, right? Let me move this slightly this side. Can I move it? I'm just moving a little bit like this for you for readability. Okay, if num equal to num is 3, so you are going to push the number 3. So this num here will be 3. Okay. Okay, so when you push number 3, then you are saying return factorial. So you are calling, what is this called? This is called the recursive call, right? Remember we talked about recursion. Now it will be num minus 1, 2. So you are again in this program. Now you are going to fall into this loop called if num equal to 2. So then num equal to 2, you are pushing 2 and you are pushing 1. Okay? Then integer result equal to 1, then you call the display function. Okay, so that means if this is an array, say if I can show an array here, insert table. Let's say I just push these 3. Okay, so you are getting values of, you push 3, you push 2, you push 2, and you push 1. Okay, after you push 1. Okay, then what are you doing here? Then you're calling display. Okay, you get the idea, right? How to trace it. So now I go to display. Okay, printf the stack. If I equal to 1, I less than or equal to n. Okay, that is size of the array, I plus plus. Piece of code is a little bit not too elegant, but you get the idea. So you are going to do a print of stack of I. Okay. So you're basically displaying all the stack contents, okay? After you display the stack contents, you're doing a pop, right? If n equal to 0, stack is empty, nothing can be done. Otherwise, else, result equal to stack of n. So n is starting from 0, or in this case 1. So you are going to now send 1, right? 1, 2, 3 in the reverse order, okay? Display return result, okay? So you click like that and ensure that you understand that you get factorial 3 equal to 6 by tracing this code. Okay? That is how you try to do the factorial calculation. You're using the stack operation implemented as an array, and then you're able to calculate it. Now, you don't need to use stack only for that, okay? You can use any kind of, in general, you can use different types of data structures. But since we are talking about stacks here and implemented as arrays, we took this example. Okay. Now, I'm going to stop here because I really want you to do some couple of those exercises in the class. Here is a take-home assignment for you. Infix to postfix transformation. So, what is infix? Infix notation is what we understand, right? Like if I say A of 5 plus 2 star 15 minus 9, right? So when standard, the one that we are used to. What infix means, the operator comes between the two operands. Okay? So that is the infix notation. Okay? Now, the same thing can be, if you do postfix notation, it looks like this. Meaning the notation, the operation comes after the numbers. So if I say postfix notation, I want some faculty members to help me. It's been a long time since I did postfix. What is the postfix for the numbers that I have written there? I think 2 star 15 comes first, right? Because I think multiplication takes higher precedence, if I remember right. Can someone help me with the postfix, please? One faculty member there. Is it 5? The way it looks like is 5, 2, spaces now. 15. I don't know if I can do 215 star minus 9. 215, 9. Let me take simple example and I'll explain to you. If I do in postfix, let's say I have to add numbers 5 plus 2. This is the infix notation. Okay? Whereas I want to do 5, 2 plus. That means you're saying, hey, plus sign takes 2 operands. Whatever is coming to the left of it, the left 2 operands you take and do the addition. Okay? I think in this case what happens is I do 5, 2, 15 star. Okay? And then I do 9. It doesn't matter whether you do 9 or not. 9 minus plus. So if I do this one, when I'm traversing this one, I see star here. So star says multiply the previous 2 numbers, 2 and 15. So they get multiplied. Okay? So that is over. Then whatever the result is 30. So that will be 5, 30. If I go down here, that will be 5, 30. I thought some faculty member would have already put something there already for me. 5, 30. Star is already done. Then I have 9. Then I have minus plus, right? So traversing, I see minus. Minus means these two, previous 2 digits. So you do 30 minus 9. 30 minus 9 is 21. So I'll have this as, sorry, Control Z. I'll have this as, students, you can correct me if I did anything wrong, okay? 30 minus 9 is what, 21. And then I'll have plus. Now plus says, okay, take the previous 2 digits and add them up. So it will be 26. Correct your rational value? I think I did it correctly, right? If I see 5 plus 2 star 15, 2 star 15 is 30. 5 plus 30 is 35. 35 minus 9, 26. I think I got it right. Okay? Okay, so that is postfix notation. Now, whenever we are doing the infix to postfix notation, the stack using an array is a classic example of transforming an infix assignment to a postfix assignment. Because you're always popping from the top. If you see the operands there, the operands are coming from the top. So they bubble up to the top of the stack. And then when you see the operand, you say, okay, I see, based on the operand, you take the corresponding numbers, pop out the corresponding numbers out of the stack. That is what you're doing there. Okay? I'm just setting the stage. I want you to go read about infix to postfix. And then when we come back next class, we'll review the example more completely. Okay? But first I want you to do your part. Okay? Just another heads up. Same thing. In general, whenever you want to evaluate arithmetic expressions, stack comes in very handy for you. Okay. So that's what I wanted to cover today. Stop here in terms of the lecture today. Next class, we'll finish the infix to postfix, and then we'll also wrap up Q, complete Q structure. Okay? Questions, comments before I make you use the next 15 minutes to work on the traces here. Okay, no problem. Where was the exercise here? Let's go back to exercise now for the next 15 minutes. Faculty members, please facilitate that. Okay. Give me a second. Yeah, this is the one. So where we are saying trace, this trace was reversing a list, right? I want you to get practice on reversing a list. Or if you take this one, insert 4 elements. Please write them down somewhere. Insert 4 elements, print the elements, reverse the elements, print the elements. So when you insert these 4 elements, 10, 20, 30, 40, okay, into an array, whichever way you do it based on the program that I showed you, print them, and then the second time you print, they should be in reverse order, 40, 30, 20, 10. Okay? Any 4 elements. It could be 1, 2, 3, 4. Okay? So reversing a list. So I have 2 sets of slides here. I'm trying to see how I can combine them into one. How can I combine them? I cannot combine them into one. I can put them in the chat, okay? How about I put the contents in the chat so that way you can see it and then execute your test code there. Okay, see how I traced it, right? I showed you how I traced it. So you just have to do it like that. Did my code come there? I didn't see it. Okay, can you hear me? Did I lose the contact? Okay, I'm trying to put the code in the chat. Basically, I'm making you trace it for those 4 elements. Okay, insert the 4 elements, print them first, then you reverse them and print them again. That is the exercise in the class. It's not even exercise, it's tracing the code. I already I'm giving you the code, right? Okay, why I'm not able to... Okay, 1 second. For some reason, my chat is not working. Let me close it and open it again. I got it. Okay. Thank you, Chakravarti. Discussion is an exchange of knowledge and argument and exchange of ignorance. Okay, excellent quote. I like that. Okay. One second. Don't put anything. Don't put anything in the code yet. Okay, I posted that code. Slow. Okay, I pasted the code there. So insert the exercises. So exam reverse. I'm getting some chat. Hold on. Okay, I have muted all participants, I think. Okay. So I posted all the code in the chat. You can take a look at that. Oh. Okay, so I posted all the code in the chat. I muted JNTV, I muted everyone. So, and the exercises. Trace the program with those insert 4 elements, print the elements, reverse the elements. Okay, take a look at the code. Faculty members. That way they get a good hang of it. What reversal of the linked list, how it works using the stack. While you're doing it, if you have any questions, comments, please put them in the chat and I'll try to address them. Great quote. Yeah, we need discussion. This class somehow was a little bit shy today. Maybe they still have the hangover of the bund, or they are already waiting for the Olympics show this evening. Don't forget too much Olympics opening night, right? I think it's Friday night our time in US. That must be Saturday morning, I guess, for you, or tonight. Okay. And here, folks, please put your questions or comments there. You can expand the chat window, as most of you know. I put all the 4 sub-programs there. I don't see any video of anyone. Do this exercise in groups of 2. Okay. Faculty members, give me some feedback. I don't see the videos. If the students are able to do it. If they're having any difficulty, please guide them. The code is right in the chat. So when they're tracing it, they should start tracing it like how I showed the nodes like this. Let them build a node, and then it's best if they do it with pencil. That way they can erase the links and redraw the links easily. Little bit challenging if they do it with a pen. You know, Chakravarti, I admire your persistence in telling them to discuss more. Right? So students have to come forward, post questions in chat. But they are very active in the community though. That's one thing that I've noticed. They have to be more active in the class too. Unless this is too deep for them. I do not know their programming competence, right? I'm sure they're genius programmers there. But as a general programming competence level, I don't know from here, sitting here. So all the faculty coordinators here, they help me coordinate that at your end. Every single topic in this class, you would see a lot of code to explain the concepts. Okay, I'm just here only, looking at these. When you trace, you will get more questions. Okay. For those of you who have done the tracing, you may want to do the tracing of factorial and make sure the factorial code that I put there. I'll upload this slide deck also in the community. So make sure you get, when you do it as a take home, make sure the factorial calculation is working correctly. I think that when I was explaining, somehow I felt that something was not quite right. Okay, let me be honest with you there. Somewhere I think something was missing, but I could be wrong. I did not trace it before I came to the class. And when I was explaining it to you, somehow for a second I felt there's something wrong with the factorial code. So I want you to trace factorial also when you go home. Remember how I did factorial number 3? Right? I want you to trace it factorial 3 all the way, and then make sure it is printing out correctly. Okay? Okay, JNTU, I see your picture finally. Were you able to trace it? Show of hands. How many of you traced it? Reverse of the list. Was anyone able to complete the trace? Not a single student completed the trace yet, okay? How many of you haven't tried it? I see one student raising their hand, that's good. They can raise it high, so that way all the other colleges can see it too. I want you guys to have fun. This is all fun thing. If you are not enjoying, then you will not learn, you know. You can see our mentor Chakravarti is trying to motivate all of us there with his wonderful statements there. That is, there are no shortcuts. As I told you, right, I don't consider myself a genius programmer at all. All of these things, as I told you, right, today I give myself like a 6 or a 7 maybe, being generous, right? My kids probably can do better programming than I do. But what I do have, which they don't have, is I know how to do these things methodically, like by tracing and doing all of those things, right? Because that teaches you fundamentally how to think, how to solve problems. It's very easy to hack code and then rely on a compiler to correct your mistakes, right? But that hacking may not teach you the right way to solve problems. Tracing stuff on a piece of paper is what develops your critical thinking. Okay, that is what we are trying to do here for you. Okay, any questions, comments, or should I sign off now? I'll be here for some more time. I'm not in a rush to go anywhere. Okay, and students, don't feel shy, and if you have any questions, just send me an email. Okay, and usually I'm a 24/7 person, meaning I hardly ever sleep. I'm awake till 1:30 a.m. every single day. Okay, right now it's midnight. I'm awake till 1:30 and then I respond to emails quite promptly. Don't be afraid to send me questions. Okay. Chakravarti garu, so are we talking about an extra class before the internals? You have any ideas on that? It would be helpful if we have at least one extra class before the internals start on the week of 18. I'm assuming we have full week classes next week. Cannot afford to lose.
Yeah, I'll plan it and send one mail to you and all the participants.
Okay. I will post this in the community right now. Let me fill it.
Yeah.
I'll post only a subset of the slides because if the file size exceeds 2 megabytes, it won't let me post. So I'm going to post a few of these things in the community. The tracing of the code for reversing of the list, I already, I think, posted it in the community last week. I did not post factorial. I'll post that after the class.